Hello students, hope you all are doing well. In the previous video we had learned about valence electrons. Valence electrons, that is the number of electrons in the outermost orbit of an atom. Okay. Today we will be learning about valency. You must have heard about valency many a times, and it is also required to derive the chemical formula of an element. But now let us understand what is valency. Valency is defined as the combining capacity of an element. Now when we say combining, what is meant by this combination? This combination means that when elements combine together to form compounds, this chemical combination is also known as chemical bonding. So whenever an element combines with another element or more elements to form a compound, then transfer of electrons takes place. When we say transfer, it may be gain of electrons, loss of electrons, or sharing of electrons. So valency is equal to the number of electrons that are lost, gained, or shared during a chemical combination. Now let us understand this through an example. Here we have taken two elements, sodium and chlorine. Sodium is a metal, whereas chlorine is a non-metal. Let us first see what is the electronic configuration of sodium. The atomic number of sodium being 11, the electronic configuration will be 2, 8 and 1. That is, it has 2 electrons in its K shell, 8 in the L and 1 in the M shell. Similarly, if we come to chlorine, its atomic number is 17 and the electronic configuration of chlorine will be 2, 8 and 7. Now if they undergo a chemical combination, now let us see the combination between sodium and chlorine. If sodium has to combine with chlorine, so in order to become stable, the sodium atom needs to lose one electron from its outermost orbit in order to become stable. If it loses this one electron, the electronic configuration will be that of the nearest inert gas, that is neon. So this one electron is lost from the sodium atom when it combines with another element. So this electron decides the valency of sodium, that is equal to 1. 1 electron lost, valency is equal to 1. Coming to chlorine, if it has to combine with another element, in case of the combination between sodium and chlorine, if chlorine has to combine with sodium, again to attain a stable configuration, or in order to become stable, it should have 8 electrons in its outermost orbit. So to complete its octet, chlorine needs to gain 1 electron. So this 1 electron which is gained by the chlorine atom, okay, if it has to gain 1 electron, this 1 electron which will be gained decides the valency of chlorine, that is equal to 1. So the combining capacity of chlorine is 1 as it has to gain 1 electron. Technically, if we try to calculate valency, okay, we can also understand it in terms of valence electrons. That is, in any metal, the number of valence electrons determines the valency of that element. So in the case of metals, the valency will be equal to, I am writing V for valency. Valency will be equal to number of valence electrons in the atom of that metal. So in case of metals, valency is equal to the number of valence electrons. So if the number of valence electrons is 1, 2, 3 or 4, the valency will be the same as the number of valence electrons. Okay. Coming to the non-metals, valency can be calculated by subtracting the number of valence electrons from 8. Since it needs 8 electrons electrons to complete its octet. So we will write valency is 8 minus number of valence electrons. So to calculate valency easily, you can calculate it this way. If the valence electrons is 1, 2, 3 or 4, it will be the same as the valency of that element. If it is more than 4, subtract it from 8 and you will get the valency of that element. I hope students you have been able to understand what valency is. In the next video, we will be studying about such elements or species of such elements which have similar chemical properties or physical properties and different chemical or physical properties. Till then, keep learning. Thank you.